Good morning, everybody. We would like to welcome you into the Kumo Theater. Our first speaker taking the stage right now. We've got comfortable chairs. Bring your coffee. Come on in and join us here at the Kumo Theater. All right, without further ado, I would like to introduce to you, and please give a big welcome to Steve Newman from Scalar. Woohoo! Let's hear some cheers. There we go.
Thank you. So today we'll be talking about better logging for faster issue resolution. Just basically, sorry, this keeps advancing without me telling it to. Sorry about that. Worked fine a few minutes ago, but so.
Sorry, buddy. I'm going to turn this off. It seems like we had some interference, and maybe we'll just have to use the laptop.
Okay.
I apologize.
Thank you. So basically, we're going to be talking about what you can do with your logs today to help you solve issues as they arise tomorrow. And the talk's going to be pretty much divided into two parts. The first part is going to be around what kinds of things you should be putting in your logs. And the second part, I'll work through three different scenarios of a real-world problem you might want to solve and how you could go about diving into your logs to do that. All right, so what you want to put into your logs. I'm going to talk about this in three parts. You want to include, at a high level, any event that you might need to know about, because then when you're in the thick of it trying to solve a problem, if the event's not in the log, then it's too late to do anything about that. So you want to make sure any event you're going to care about is there in your logs, and that log message has enough details to actually help you track down what the event was, what caused it, how it correlates with the issue you're investigating. And ideally, you want all of this in a format that's both readable by you, but also parsable by your tools for analysis. This is very high level and abstract. Let's dive in a little bit and talk about what each of these things really means. So what's an event that you might need to know about? One large category of that is information that will help you localize or narrow down a problem. So if you're running a big, complicated system, a lot of services, a lot of problem solving or investigation is just localizing the problem. Is this in my web server? Is it in my database? Where in my complicated system is this problem originating? That's half the battle. And so if you have information in your logs that talks about the communications between those systems, whether it's between different services and servers or between different components within a single process, if you're logging requests and responses, that's invaluable in narrowing down a problem. If you can ideally you want to log both sides of that, the client and the server, but if you're going to pick one, it's best to log on the client side, because that way you're always sure that something will get into the log even if the server isn't functioning. The other big category of things you want in your logs can be summarized as unusual events. So that includes any kind of an exception or stack trace or error code, or anywhere maybe you have like a rate limiter or a cap or a throttle that sometimes kicks in to protect your system. Unusual paths through the code, an if branch or some other branch of the code that you don't normally expect to see. And the last thing that's usually a good idea to log are large or dangerous actions, like deleting a file or a new user signing up for your system, sort of large heavyweight actions that by their nature don't happen very often, and so it's sort of easy to afford the logging for those. And so then including details in your log message. You want to, when you look at a message and you see that a certain event occurred, you want to have some idea of why this occurred, who asked us to do this, which IP address or which user or which upstream service issued this request. What kind of data are we operating on? What record ID or user or other specific information is being processed here? Who is going to be affected by this? If I'm seeing errors or problems here, which one of my customers or client services requested that so I know, who's impacted? And ideally, you want to log all of the input data to each operation, because that'll help you reproduce. If there's a problem, knowing what the inputs were will help you reproduce it. So here's a concrete example of a bad error message that kind of violates all of these rules. and doesn't have any information. And sadly, this is a fairly realistic example. I've seen things like this in the wild in a log. So this is an error that's being logged at some low level in a system. It really doesn't give you any information to track down the problem. Here's maybe a little bit better, where now the message is including some data that was available locally at the place where the error was detected. It's probably still not going to help you localize the problem, but it might at least give you a hint. Here's something that's much better, and hopefully more what you want to aim for in practice. So we've got the same as the last slide, an error message and a little bit of local information about what was going on when that error occurred. But we've also included some information that would be available at a higher level, maybe where the exception has been caught. We were in an RPC handler when we triggered this error. Here is some information about the parameters to that RPC. And hopefully a stack trace. So again, you can't necessarily have that information available where the error occurs, but if you're throwing that up the stack and catching it at the top of your code, you should have all this information, and by logging it, you now have much more ability to figure out where did that error come from, why is it happening. And here's kind of a best case. This is actually a real world, or derived from a real world example in some of our code. We have a system that rewrites all of the HTML that we serve out to any browser as a filter kind of at the last step of our request processing. Rewrites it to reduce the size and speed some things up. Every now and then it will fail, choke on some funny input data. So we actually, when that happens, we log the HTML file to disk on our server so we can go back and reproduce the problem. So this is something that won't fit directly in your log, but you can put a reference in it. We put a rate limit on this, so if suddenly we started having this happen a lot, it wouldn't fill up the disk on our server. But just by logging one or two of these, it immediately makes it very easy to reproduce and track down a problem. And so I talked about a format that's both human readable and machine readable. So here's your kind of classic printf debugging log, maybe pretty easy to read, but it's very difficult to parse. It's a very ad hoc format. There's a modern trend toward putting logs in JSON format, obviously very easy to parse, but it gets kind of hard to read. You have field names on things that don't really need them. It's pretty obvious that that's a timestamp. You have a lot of extra quoting. The fields are maybe in some random hash table order. Here's a compromise I really like, where you have a fixed format of maybe something like timestamp, host name, and a message. It's a fixed format so a machine can parse it, but it's also very natural for someone to read. And then if you have additional structured data, you can put that in a key equal value format. It's kind of like JSON without the quotes. Still pretty easy to parse by any decent log management tool, but it's also still pretty readable. And then logging, like any other software, is never done. So you always want to iterate. If you're tracking down a problem and the logs didn't have enough information or was hard to work with, go back and for next time, add more logs, revise your logging. If the logs are too noisy, take something out. You should always be iterating on this just as you're iterating on everything else in your system. And just a few other quick tips. I talked about some logging, you might want to include a rate limit, especially things that can spike. So maybe your database server goes down and you're logging thousands of stack traces per second, trying to talk to the database. You'll flood your logging system. So error logs and stack traces especially are a good thing to put rate limits on. If you have a runtime configuration system where you can turn logging on and off on the fly, that gives you the freedom to leave a lot more logging in your system with a lot of it turned off. And then you'll have the ability to turn that on when you need it in an investigation. So now I'm going to talk about a couple real-world scenarios where you might use your logs to solve a problem. I'll start with troubleshooting. It's a broad category where basically you've noticed a problem. Maybe one of your users reported it. Maybe your alerting system let you know. But you have a symptom. Your site is down. It's slow. People are getting errors on a certain page. There's some kind of symptom, and you're trying to find the root cause. The general approach is to first identify a log that bears on the symptom. If you're serving errors, hopefully you have an access log or a debug log that's recording those errors. If you have a performance issue, maybe you have a log that's logging your response time. If a service is overloaded, you look for a log that records every access to that service. So now you have a log that correlates with the symptom. Then you're going to use your log management tools to start breaking that down. Are these problems localized, particularly on one server? Are they associated with a particular web page, a particular client IP address? Did they all start happening at a certain point of time? You want to look for the pattern in that data that's going to point you maybe at a cause, or at least get you one step closer to the cause. And then you may have to iterate, keep drilling down. The site is slow because the database is slow. Now you're investigating why the database is slow, but you're one step closer to that root cause. A critical enabler for this in advance is to have parsing rules or something set up that can extract the structured data from your log so that you can do that analysis. You can get roll-ups by IP address and service name and so forth. That's going to allow you to do the kind of exploration that will get you to a root cause. So here's a quick little demo video in our product, Scalar, that kind of illustrates this. We're looking at, in this graph here, a performance of a web server, and we can see we're having these spikes, that we have some kind of a latency problem. There are a few different metrics being graphed here. I'm going to turn some of those off and just look at the median access time. We can see in the median the spikes don't show up. So that tells us that our performance problem is affecting less than half of our traffic. Maybe we have some kind of a long tail latency issue. So we're bringing up a view now that shows us the distribution of access times, and it's mostly less than 50 milliseconds, but we have a long tail. So we're going to type in a query to look only at times more than 1,000 milliseconds. Let's just look at these slow requests and see whether that helps us figure out the root of the problem. So here's a bunch of different requests that all took at least 1 second to process. These requests each have a unique ID that lets us follow the request through the log across different servers. And when we look at one of those slow requests, we can see that there was a step where it logged this funny error message, inconsistent friends list, which is a made-up message but illustrates, maybe an obscure error message you might see in production. So now we search for that message, and we can see it's happening a lot. And on the graph, we see that these error messages are coming in waves that line up with the performance problem we saw at the beginning. So now we have a pretty good guess that this error is the root cause of our latency problem. As a last step, we can go and save this search, this error message search, into a dashboard. So then we'll have it for quick reference if we're investigating another problem in the future and we suspect we might have this same cause. I'll talk about that again in a moment. So now I'll talk about firefighting. Firefighting is basically the same thing as troubleshooting. You've got a problem and you're trying to solve it, but it refers specifically to when the problem is something of an emergency. You need to solve it very quickly because it's really affecting things. So to set yourself up for success in firefighting, you're going to want to be able to find quick answers to common or frequent problems. So setting up these searches in advance based on things that may have happened in the past is going to help you do that. So here's an image of a dashboard I might have been able to create just by saving that graph that I had, or that search that I had at the end of the video clip. If I throw onto this dashboard over time different searches, different problems that I found have come up in the past, then I can bring this up, and at a glance, your eye is very good at looking at a set of graphs and immediately noticing which one is spiking or which one looks funny. So by putting sort of your usual suspects of things that have happened in the past into one dashboard, you give yourself a quick overview, and then in a tool like ours, you can then dive into one of these graphs and immediately start exploring the data behind it. So you're on your road to finding the root cause. And finally, I'm going to talk briefly about load analysis, which is figuring out what's driving the load to a system. Maybe you want to tune that system, or do a capacity analysis, or figuring out why is it being overloaded. We need to reduce the load. So you want to start with some log data that reflects the usage of that system. Now some systems, kind of every request has the same size, and you just need to look at log every time something happens. Some can have variable sizes. Downloading a file is very different for a big file than a small file, and then you need logs. with information about the size of the operation. So you want to log any expensive operation that the system is performing. And if you have variable-sized operations, then you want to log a numeric parameter like the time spent or the amount of data transferred. So here's one last quick video to explore that. We're looking again starting out at a dashboard for our web cluster. We're going to look at this graph that shows the amount of data being transferred out of the system. And over here on the left, we've got this facet breakdown that shows the most common pages accessed on the site. But those common pages may not be the ones that drive the most bandwidth. So we're going to go here to what we call a breakdown graph that breaks down the y-axis, the data transfer, by URL. And so on the right, we can see, you can see two graphs are kind of rising to the top. That's most of the bandwidth in our system. And it's 2 pages associated with image rendering, which are not the most common URLs being accessed on our site. But the breakdown graph shows us that by analyzing this numerically, we find that actually the bandwidth is coming from those specific pages, even though they're less frequent in terms of how often they're accessed. That's all my slides. That's all my time. Thank you for coming, and I can stand down by the entrance. If anyone has any questions, please come up afterward. And that's that.
All right. Thank you so much, Steve. Appreciate it. Kicking us off this morning.